So now we're going to deal with how do we work out the equity that our hand needs, or the probability that it's going to win, to make a call break even. Because in the last video we had a situation where our hand was actually not the best hand, and then it was still plus EV to call, even though we had the worst hand. So what we're going to try and do is work out, well, how good does our hand need to just be, just make it to justify a call? So let's say it might just be, our break-even percentage might be 37%. We need to win 37% of the time. So if our hand wins more than 37% of the time, we call because we know it's plus EV. Okay. So the question is, how often does the hand need to win to break even? Or, what do we need the probability of winning to be? Okay, if we call. So here we've got us here, and we're making a decision. Our opponent's gone all in and has made this yellow bet, and this bet we're going to now give it the notation of B for bet. And remember that this bet is also our risk, the risk that we're going to have to take to win the pot. And this here is the pot, and that equals P. Now what I want to do is I just want to throw in a bit of pods that we did from earlier. If you haven't watched it, it might be worth watching the pods video. And remember that pods are basically reward to risk. Okay, now our risk obviously is this yellow block here. Okay, that's our risk. Our reward equals this bet here. Okay, this bet, hang on, that's no good, I don't like that colour. That won't do. There we go. This bet here, because if we win the hand, we'll get our opponent's bet and the pot. Okay? Hopefully that makes sense. So then, what do we need to do? Well, let's get the EV equation that we had from earlier, that we made. We'll write it out. So, EV equals the probability of winning times by how much we win, which I'm going to call W, that's our reward, minus the probability that we lose times by our risk. Okay, now what we're going to do is we're going to set this to equal 0, because if our expected value is 0, we are just winning the hand often enough to make the expected value equal 0. So if we win any more often, then this threshold is going to be plus EV. Hopefully that makes sense. So, now let's just consider a few things that we can actually work out. We know that if we call, one or two things has to happen. Either we win or we lose. So the probability of winning and losing, winning or losing, must equal 1, because we either have to win or we have to lose, so it's certain. So we can rearrange the probability of losing to equal 1 minus the probability of winning. Okay, and we can use this and substitute it into this equation here. Now then, there are other little bits of data that we need to consider. We need to consider our W term here, how much we win, which equals the pot plus the bet. So we'd win this stack here, and we'd win this stack here if we had the winning hand. And we need to consider what our risk is. Our risk equals this stack here, because we have to match the bet. So our risk equals B, the bet. So if we substitute all of that in, we are going to get probability of winning times by the pot plus the bet, so this is the reward term, minus the probability, minus 1 minus the probability of winning. So we've used this term here and substituted that term in for it, times by our risk, which is equal to the bet. And we're going to set this to equal 0 because we're just going to break even. So expanding out this one here on the left, probability of winning times by the pot plus the probability of winning times by the bet. Okay, and then expanding out this bracket here, it's going to be minus B plus probability of winning times by the bet. So that equals 0. Okay, I'm sorry if this is looking a bit odd, but you'll see where we're coming from when we get to the end of this. So we can rearrange this, and we can factorize the probability of winning terms here. So this one here, they've all got probability of winning on it. So we can factorize it, and we can make it probability of winning equal times by, open the bracket, the pot plus 2b. Because we've got one term with just the pot attached to the end of it, and then we've got two terms with the bet attached to the end of it, equals the bet. Okay, because here we've got this bet term here, and all I've done is I've pushed it over to the other side, so it's just gone over there. Okay, so I've expanded it out, I've expanded our equation out, and then I've factorised it, and then we're going to find the probability of winning equals b over p plus 2b. So this is saying the probability that we win to break even needs to equal the bet that our opponent makes over the pot plus 2 times our opponent's bet. And it should make sense to you that this is always a fraction, because we've got b here, which is a number, and then we've got 2b here, which is the same number times by 2, so the top of the fraction is always bigger than the bottom of the fraction, so we always have a fraction. We don't have a number like 3 popping out. So how is this useful? Well, we know from earlier that our reward equals p plus b, the pot that we win, one of the stacks, and then the bet that our opponent makes. And our risk, this ties in from our pot odds stuff, equals the bet our opponent makes. And we can substitute this in to this formula here, okay, this information, and we can say, well, at the top we've got b, and we've got risk here, which also equals b, so the probability of winning equals risk over, and then we've got a p plus b term here, plus another b on the end, because I just want to write this out, p plus b equals p plus 2b. So we can say, alright then, well, we've got p plus b here, that does this, so this bit here goes to there, so we've got reward, and then we've got our risk, which is this b term here, so it's risk plus risk. Okay then, and that solves, so all that algebra comes down to this, that we need to win, to break even, risk over reward plus risk. So how does this manifest itself? Well, let's say we've got pot odds of, let's say we've got pot odds of 2 to 1. Okay, that means, well, this is our reward, and this is our risk. So substituting that in, the probability that we win, or, you know, our equity, well, equals our risk, which is 1, over our reward, which is 2, plus 1, which equals 1 over 3, which is 1/3, which equals 33.3%. So to break even, our hand needs to win 33.3% of the time. So hopefully that makes some sense. That was a little bit complicated. It's probably worth watching it through again if it didn't make sense, or leave a comment below if you didn't understand some of the algebra or the expansion. But this is the key thing here, this formula here, the equity we need to break even is equal to risk over reward plus risk, and we can find those terms of risk and reward from our pot odds that we are being offered. So our pot odds and our break even sort of thing are interlinked, so it's well worth watching the pot odds video if you haven't, so that you can understand that these two ideas are linked. Okay?